Welcome to this explainer. So we're going to let you in on a massive secret today, the hidden key to chemical equations. Look, if you've spent any time studying chemistry, you know the drill. Balancing equations can feel like, well, a giant puzzle. You spend all this time counting atoms, tweaking coefficients, making absolutely sure the left side perfectly matches the right. And when it finally balances, boom, massive relief, right? You probably think, awesome, I'm done. But actually, scratch that. Stopping there is exactly what separates average chemistry students from the absolute top scorers. There's this hidden layer, a final polish, that takes your work from just okay to undeniably correct. And if you think it doesn't really matter, well, consider this. 71%. Yeah, just let that sink in for a second. That is an incredibly heavy reality. Nearly 3/4 of students are making a critical error on their exams when they write out chemical equations. And it's not because they don't know the chemistry. It's not that they can't do the math to balance the atoms. It's something that seems so much smaller, yet it is vastly more costly to their final grade. That's 71% of students. They lose marks right here. They fall into this massive trap where they assume the job is totally done just by balancing the equation. They do all the heavy lifting. They balance the calcium, the carbon, the oxygen, and then they just drop their pencil and move on. But by doing that, they're literally throwing away easy marks. Why? Because they forget one absolutely crucial layer, indicating the physical states of the reactants and products. See, a chemical equation isn't just a math problem on a chalkboard. It's a story about reality. In a real lab, mixing two liquids behaves entirely differently than mixing a solid and a gas. The entire role of state symbols is to give you that vital physical context. If you leave those out, you're leaving the story half finished. Okay, let's dive into this. Let's break down exactly what a fully written chemical equation actually needs. There are 4 critical state symbols you've got to master. And honestly, they're beautifully simple. A lowercase s in parentheses, that stands for solid. A lowercase l is for liquid. A lowercase g, gas. But I really want to draw your attention to that last one, because this is where a lot of people get tripped up. AQ, which stands for aqueous. Now, aqueous simply means the substance is dissolved in water. It is not the same as a pure liquid. Like if you have solid salt and you melt it at some crazy high heat, that's a liquid. But if you take that same solid salt and just stir it into a glass of water, that is aqueous. Knowing the difference and just popping these little lowercase letters next to your formulas is exactly how you stop losing those easy marks. Let's actually see this transformation in action. So here's what I like to call a naked equation. We've got calcium carbonate breaking down into calcium oxide and carbon dioxide. And sure, it's chemically balanced, the atoms perfectly match up. But it kind of feels empty, doesn't it? Now compare that to the fully dressed equation. The CaCO3 gets an S for solid. It breaks down into CaO, which is another solid, and CO2, which is a gas, shown by that little G. Suddenly, you aren't just looking at random letters anymore. You can literally visualize a solid chunk of material breaking down and releasing a gas into the air. This fully dressed version is the only one that's completely correct. It's the difference between just doing the bare minimum and showing absolute mastery of the subject. But let's build on this, because state symbols, they're only half the secret. The other half is what we call reaction conditions. See, a fully written equation also needs to explain how the reaction actually happens. Think about that reaction arrow sitting right there in the middle of your equation. It's not just a pointer to the right, it's prime real estate. The space directly above that arrow is where you specify the exact requirements needed to make the reaction happen. This could be the Greek letter delta to indicate heat. It could be super specific temperature or pressure values. Or maybe it's the name of a catalyst that speeds the whole shebang up. The crucial takeaway here is that a reaction doesn't just magically happen in a void. It requires a specific environment, and you have to document that environment right there on the arrow. And this brilliantly illustrates why all of this matters so much. Take the reaction that creates water as the perfect example. A naked, perfectly balanced equation just tells us 2H2 plus O2 makes 2H2O. But look at the fully detailed version. We have our gas and liquid symbols, sure, but notice the trigger right above the arrow, an electric spark. You see, hydrogen and oxygen gases can mix together in a balloon all day long and do absolutely nothing. But if you introduce an electric spark, boom, you get a rapid reaction and you get liquid water. The detailed equation tells the complete, scientifically accurate story, while the naked one completely leaves out the trigger. Which brings us to the ultimate payoff. The CBSE board gives a very direct tip for exams, and honestly, it acts as the behavioral secret of the top 1% of students. It explicitly states that a balanced chemical equation question is only fully correct if both state symbols and conditions are included. So those 71% of students we talked about earlier, they are missing out on 1 to 2 extra marks every single time they write an equation. The top scorers, the true toppers, they've made this an automatic habit. They never leave an equation naked. They add the S, the L, the G, the AQ, and the conditions every single time. It's just a tiny amount of extra effort, but it shows complete chemical fluency, it guarantees success, and it definitely secures those top grades. So by mastering these state symbols and reaction conditions today, you've just leveled up your chemistry skills immensely. You now know exactly how to write an equation that tells the full, complete story. And most importantly, you know how to secure those marks that everyone else is just leaving on the table. But this is really just the beginning of understanding the secret life of chemical reactions. Now that you've mastered states and conditions, are you ready to look at reactions by their energy? Keep that question in mind, because that is where the real power of chemistry gets unleashed. Thanks so much for joining me for this explainer, and I absolutely can't wait to see you dive into the next topic.